Exterior angle theorem. The exterior angle theorem states that the measure of an exterior angle of a triangle is equal to the sum of the remote interior angles, or the angles that are not directly next to one another. So angle 1 is that exterior angle, and angle B and angle C are those remote interior angles. This angle here, angle BAC, is adjacent and interior of the triangle, and it's adjacent to angle 1. So we want the non-adjacent or remote interior angles. We will use what we learned about special angles to see why and how the exterior angle theorem works, and then we're going to practice applying this theorem. Let's draw a line through point B parallel to segment AC from our original triangle ABC. So we're going to draw a line straight through point B, we'll call it line K, and it's parallel to segment AC, or line M, and we have some transversals in here. When we have two parallel lines cut by a transversal, we're going to use those properties or theorems to prove that the measure of angle 5 is equal to the measure of angle 1 plus the measurement of angle 3. If we look at transversal P, we can see that angle 3 and angle 4 are congruent to one another because our two parallel lines are cut by a transversal, and then the alternate interior angles are congruent. Similarly, if we change our transversal to be line N, we can see that the measure of angle 5 is congruent to the sum of angle 1 and angle 4 together, or their measures are equal to one another, because angle 5 in combination with 1 and 4 together are alternate interior angles. So when you add up 1 and 4, they will equal the measurement of angle 5. Therefore, the measure of angle 5 is equal to the measurement of angle 1 plus the measurement of angle 4. And then we can take angle 4's measure and substitute or fill in angle 3's measurement because 3 and 4 are congruent. So if we put measure of angle 3 in the measure of angle 4's spot, we will get that the measure of angle 1 plus the measurement of angle 3 is still equal to the measurement of angle 5. Now that we know that the exterior angle theorem is indeed true, how can we apply it to find the measurement of angle 1 in this diagram below? Well, what the exterior angle theorem states is that the exterior angle, or the measure of the exterior angle, is equal to the measurement of the other two angles in our triangle that are not next to it. So if I was to label this A, B, C as our points, it would be the measure of angle A plus the measurement of angle B. So let's apply that with the numbers that we have here. Measurement of angle 1 will equal 27 plus 105, and if we add them together, that will give us 132 degrees. And that's how we find the measure of that missing exterior angle. What is the measure of angle 2 in the diagram below? The diagram is not necessarily drawn to scale. So let's start by writing down the exterior angles theorem, which says that the measure of the exterior angle is equal to the measurement of the other two angles that are not adjacent to the exterior. So we'll have, let's call this angle 3. So we have measurement of angle 2 plus the measurement of angle 3. So now if we fill in the known quantities, we will get that 163 degrees is equal to the measurement of angle 2 plus 27. And then if we subtract 27 from both sides, we will find out that the measure of angle 2 is 136 degrees. What's the measurement of angle 3 in the diagram below? And note the diagram isn't necessarily drawn to scale. So we know that the exterior angle, which is 125 degrees, is equal to the sum of the two interior angles that are not next to it or not adjacent to it. So that'll be 95 plus the measure of angle 3. So then if we subtract 95 from both sides, we find that the measure of angle 3 is 30 degrees. And yes, here's the work required to solve this problem, and it matches the solution that we found, that the measurement of angle 3 is 30 degrees. Find the value of x. Note that the diagram is not necessarily drawn to scale. So we know in order to set up an algebraic equation to represent the situation, we have an exterior angle of a triangle whose measurement is 2x, and its measurement is equal to the sum of the two non-adjacent or two remote interior angles of the triangle. So that would be 70 plus 40. If we add those two up, we'll get 110, and we still have 2x on the left side, so if we divide both sides by 2, we will get that the value of x is 55. And it does make sense because 2 times 55 is 110 degrees, and 70 plus 40 is 110 degrees. And here's the solution to this problem, which we just figured out, that if we add up 70 and 40, we get 110, and that is equal to the measure of this exterior angle, whose algebraic expression is 2x. So if we divide 110 by 2, we get that the value of x is 55.